Now we are discussing conservation of momentum. If we take a gun and from this gun we have fired a bullet. Now the force acting on this bullet by the gun is F. Then force acting on gun by the bullet is minus F. This is according to Newton's third law. Every action has its equivalent opposite reaction. Now these two forces, F and minus F, they are acting for the same common interval of time, delta t. Means the force that is acting on bullet by the gun and the force acting on gun by the bullet, the time interval in which the bullet is firing from the gun is delta t. Now the momentum is nothing but F into delta t. So the change in momentum, if we get by using F into delta t, for the bullet, the change in momentum is F into delta t. For the gun, the change in momentum is minus F into delta t. Why we are taking F into delta t as change in momentum? Because the initial momentum for these two, the gun and bullet, the initial momentum is 0. Initially, they are at rest. So what is the final momentum? Final momentum is F into delta t. So the final momentum minus initial momentum is change in momentum. So the initial momentum is 0. Whatever the final momentum we have now, that is the change in momentum. So if we take the change in momentum for the bullet is PB and change in momentum for gun is PZ, then the summation of these change in momentums for bullet and gun, they are equal to 0. This is called as a law of conservation of momentum. We will take another example. If we take an isolated system in which external forces are not acting on it, in that system, then the forces, mutual forces we are taking, they are equal and they are in opposite. So they remains cancelled and the momentum remains unchanged. This is because law of conservation of momentum. So if we take an example in which two objects, two bodies are colliding, those are A and B, and their initial momentums also this time we are taking. For the object A, the initial momentum is PA, and for object B, initial momentum is PB. For object A, initial momentum is, final momentum is P dash A. For object B, final momentum is P dash B. So the change in momentum is P dash A minus PA, and the change in momentum for B is P dash B minus PB. So this is P dash A minus PA is the change in momentum for object A. The change in momentum for B, P dash B minus PB. This we are relating with respect to force into delta T. So FAB into delta T, FBA into delta T. As we mentioned, the change in momentum for an isolated system, it remains 0. So we are writing P dash A minus PA plus P dash B minus PB is always equal to 0. From that, we can derive that the final momentum P dash A plus P dash B for the both objects A and B is equal to the initial momentum PA and PB for the both objects.